Time has stopped people. Time has stopped.
Yeah, because he froze us.
I don't
It's
care.
like,
I'm being completely
no,
oblivious.
every time it stopped, then we're frozen in time. So
I wish
let's
time
go
was
with
frozen.
All right, so this is 12-1. I always like to just put it a little bit bolder on there. This is our last chapter of geometry.
It is the hardest chapter of geometry. We will say.
I want to tell you, I want to be honest with you. When I went to high school, I did not learn any probability. When I went through college, I didn't learn any probability. Okay?
Is this probability?
This whole chapter is probability. So, we don't do anything we don't have to, because there's plenty that we have to do. So, I might make mistakes, but in ways that I don't usually. Yeah.
So after like the big state test, can we just like stop doing everything spot time during the time being?
We will. Things will change a little bit.
Like what will we do?
No.
No, because we need a review for the air test.
Yes.
Because I don't remember anything I learned.
Our test is sneaking. It's in 12 days.
Oh dear.
But who's counting?
Please tell me.
Okay. So probability.
School days or like all days?
School days. So let's find our quiet note spot, aka stop talking. So I want to point out, I was going to just print this as part of the notes, the second little sheet, but it didn't fit. I was one page too big. So then I thought it made sense for this sheet to be bigger, even though it's supposed to be just part of the notes. But I'm going to keep pulling this, and we're going to add to this. And this is kind of good that it's a big sheet because it's going to be a reference sheet that we're going to use. Okay. What they're going to do with the probability in geometry is they're really going to get involved in the notation. Okay. Like we have to know how to read that. We have to be able to read what that means. My P got cut off. I'm sorry, but we got to be able to read that. Okay. And we'll talk about all those things, but they're really get into knowing the notation as well as what's going on. I kind of feel like we're probably already prepared for the probability questions. It's the notation that we're not going to be prepared for.
Just kind of off topic, but we're in the final with the final ninth period.
With who? No, it shouldn't be across grade.
Yeah, I don't know, but like on the thing.
I think the last group is, I think the last group, it does 8 versus 7.
Yeah. So there's an 8 sign and 7 sign, and grade 1 the 8 sign.
Kind of thing.
So now we're going against 7.
We won
the national championship last night? I couldn't get to watch it.
Yeah, it's
Virginia. Virginia. Okay, I wish it was my bracket.
Anything else we need to discuss before we start?
Yes, we do. I want to have $30 because my bracket got first place. Yeah, I know.
Yes.
A, and B, is that and or?
No, we'll get there. Okay. All right. So what we're going to be doing is we're going to be answering questions that I think we know how to answer, and then pulling out the other sheet and adding to what it means. Okay. So you roll a standard number cube. So you got to know what a standard number cube is. It's a 6-sided cube. Okay. Let's be focused, please. Okay. So let E represent the event you roll an even number. Okay. And let T represent that you roll 3 or 5. Okay. So even, just so we're clear, what is the even numbers?
2, 4, 6.
2, 4, and 6. Okay. And then that's my event E. And then my event T is to roll either a 3 or a 5. Okay. What is the probability that you roll an even or 3 or 5? So the way we write this is the probability that E happens or T. So that's the notation that we have to know. Okay, that means the probability of this or that. Now, had I not brought that up, I think we could have answered this question without that notation. Okay, so it's gonna, so or means it doesn't matter. 2, 4, 6, 3, or 5.
Because it says,
So we're just forgetting one?
Yeah, one is not one of the ones we're specifically looking at.
Okay, but it's a 6, 7.
Yeah, well, it's
So
one of the things that's not in the big
It's-
number or.
what is the probability of landing everything except one?
Yeah.
So to answer her question, the bottom is going to be what are all the possibilities? There are 6 different things. There's hitting 1, 2, 3, 4, 5, or 6. We want to hit 3, 5, 2, 4, 6. How many chances do we get?
5.
So our odds, the probability of this happening is 5 out of 6. We're going to answer probability questions as fractions or as decimals. Okay?
Decimal percentages?
No, decimals.
So like on the first one, instead of decimal, it should be an actual decimal, not a percent.
Correct. So, for example, what is 5, 6? This one, because it's 83.3 repeating, we want to make sure, I would really love for people not to talk during my notes today. Just, I don't know why we're doing it so much. I would really want you to lead this as 5, 6 because we can't represent this full decimal. I mean, I guess if you want to argue with me that you could say that it's 0.83 repeating, okay? But I would accept either one of those answers. If possible, let's not round, okay? So the next one, the probability that you roll, now they're going to use the word and. It's the same situation. So we want to do both hit 3 or 5 and 2, 4, and 6.
Isn't that what we just did though?
No, what's the difference between these
One
two?
of them is or, but
Right.
wouldn't that mean like? What would you wanna do?
So here's my analogy for the difference between and or, okay? When my wife was pregnant, she would say, go to the store and I want you to get pickles and ice cream, okay? I go to the store. The store has pickles, but they're out of ice cream. So what do? I have to go to another. You don't dare go home without both.
Why not?
So and means both. You have to do both. If she said, go to the store, I want pickles or ice cream, I get the pickles
Because there is no ice cream.
because they don't have any ice cream. But what then? So then I do what? I don't. You still go get ice cream.
Yeah.
But even though she meant or, she really wanted. Okay. So that's the difference in or. I don't care which one. Whatever you want. Okay. But and means both better happen.
Wait. So
What do you notice? Yeah.
It says what would you want on the same problem, but it wants 2 numbers. How does that work?
Good question. So what's the probability of E and T?
0.
0.
Really? Because you can't, if you
Oh,
roll the
you
dice
can't.
once, you can't get 2 numbers.
That makes sense.
No.
So the answer is 0. It is not possible.
Unless you have two
Because
guys.
you can't, it says but
Which
You roll 1 dice 1 time. Anybody want to guess what this is called?
I'm not guessing what it's called, but it's something. So say, what it says like, what is the probability that you roll an even number and a 4? If it was a 4 or a 6, then we could have did it because it's technically, it's only because these 2 numbers. It's not saying both of these. It's saying the even number has to be a 3 or a 5. But if those numbers were even, so we could do that
Right.
because it's that.
But it didn't do that, right? So what do you think this is called? If you look at your paper, yeah, okay, that's a really good guess. Okay, close, and it's confusing. What's the difference? But it's not independent. It's mutually exclusive. Okay, have you ever heard the terms mutually exclusive?
I've heard them.
Mutually?
Exclusive, like I've read them separate, but not.
Yeah, but never together.
Typically, when I've heard mutually exclusive, it means when you're dating somebody. What does it mean to be mutually exclusive?
To hate the same person.
To not,
Guys, listen, please.
like, no one else can. take you.
Exactly right. If you are my wife and I are mutually exclusive. If I go out on a date, it's with my wife. Unless I want to die. A slow and painful death. Mutually exclusive means that only, okay, so mutually exclusive so the definition of mutually exclusive, so let's go to definition side, okay, vocab, okay.
Is this all the vocab of this chapter?
No. So I'm going to draw a Venn diagram, okay? What's true about mutually exclusive things in a Venn diagram?
That they agree on the same thing.
They have
They have two different differences and.
Do you know what Venn diagram is?
Yeah.
Can you draw one?
Right. So this is a Venn diagram, but what would be true about the Venn diagram of E and T? Oh, I didn't draw a Venn diagram. I'm sorry.
Just drew two circles. Hey, there you go, that's the Venn
So,
diagram.
So what's true about E and T?
they're both numbers.
Okay.
There's a chance that they'll land.
So E was 2, 4, 6, and T was 3 and 5. What's true about the Venn diagram of E and
There's
T?
nothing in the,
Yeah, they have
Middle.
nothing in common.
So therefore, what does it look like?
or not that, it's just two
That
circles.
It's just, that's why I drew two circles, okay? Because the Venn diagram of this, there's no overlap, okay? So mutually exclusive means, and here's what I want to point out about mutually exclusive compared to independent, because it gets me really confused sometimes too. Mutually exclusive means one event, okay? It's key that it's one event, okay?
What does that mean?
So one event. So I rolled the dice once. Independent means I rolled the dice twice.
Wow. Okay.
Okay.
So can we just put.
Or two different things happen. So one event, okay, where one, I don't know how to say it, one thing or another can only work. Yeah.
You know, it's really hard to explain the Cavaliers' problem.
You guys did great on it.
We did.
Like,
Yeah.
like,
Did we
it was-
really?
I know what it was, but it was really hard to.
Yeah, it was.
Some people haven't tested yet, so let's not talk about that too much. Okay, so probability of ET.
0%. Sorry.
Okay,
That right?
so it's one event is kind of important, and you got to just kind of understand that if this happens, or this happens, right? But they can't both happen.
Oh.
Okay. I'm not explaining it super well, right? So I can either,
Ice cream or eat.
what's something that you could do one thing or the other, but you can't do both?
Go to Texas or go to Alabama.
Okay.
You can't like, I don't know, little kids can't have ice cream and cake.
Can't live in two states.
But you can.
Hey, you're a little kid.
So here's the thing. You can be in Ohio, you can be in California,
But you can't be a
but you can't be in both
At the same time.
at the same time.
Oh.
Not California and Ohio.
You can't be alive in both.
I mean, I agree with Arizona and what is it, Colorado, but not Ohio.
We have 4 states at once.
Correct, but you can't be in Ohio and you could be in one or the other, but you can't be in both.
Can't be in the US and Canada at the same time.
Yes, we can. I'll stand on the border.
I will stand on the border and then that's how.
This is going to be redundant, but probability of E and I'm still on the I'm sorry, probability E or T equals, so when it's or, I don't care. You're going to go probability of E plus the probability of T. You're going to just add those together.
What?
Okay?
What do you mean you don't care?
You don't, or means I don't care if you get a 3, 5, 2, 4, or 6. I don't care what you do. Or means just do one of these things. Okay? So you add them up. The probability of E and T is what? Jonathan? Did I lose you?
0 unless you have multiple things.
No. Yes, 0. We're not mutually exclusive. It's one event.
Perfect.
We're still in mutually exclusive. Okay. So this is super redundant, but we can't write these formulas enough because you have to kind of know them. So I'm going back over to my formula side. So mutually exclusive. Let's go ahead and sneak in here one event. Absolutely.
There.
I like the California-Ohio analogy. Okay. So the probability of A or B. Jonathan, you have a question?
For or, is it ever possible to have different denominators? You have to figure it.
Because it's one event, I don't think so. It is true when we get to more than one event. Yeah.
Is there like terms for like 3 events or 4, or is it just running out of terms at that point?
I mean, probably.
You mean like A, B, and C?
Yeah.
Or, oh, is there another term past independent?
Yeah.
So independent just says how they affect each other. So you could have 3 things where the first 2 don't affect each other and the third one does. Okay. But we don't get that advance.
So like those,
We only really choose them.
Basically, yeah.
so it's like those 2 friends that hate each other, but you're the person in the middle, but they both like.
Yes.
All
All right, so this is redundant, but the probability, I'm going to say California and Ohio for my probability of being in California or Ohio. That's good. Is the probability of being there plus the probability of being there. I mean, there is a case for I'm not in California or Ohio, right?
Yeah.
The probability of being in California and in Ohio is 0. Can't happen.
Wait, for the first one, would be 1/3, then probably not being in there, not being here. Or would it be?
This here
Yeah,
with the dice or what?
you said California or Ohio, so would it be 1/3?
I don't want to get, well, it depends on how I set up the question. So if I said, Mr. McConnell gets dropped off randomly in one state in the US.
It would be 2 out of
Then it'd be
50.
like 1/3.
Yeah.
I think, the better one than California and Ohio is Earth and non-Earth.
Okay.
Earth and moon.
Earth and moon.
I mean, there's
If you say that you got
Earth
somewhere, it could have been Hawaii or Alaska. Well, I guess you could drive to Alaska, but good luck. Because you might starve on your way.
The probability of being on the Earth or on the moon is, there's only been like what,
7.
17?
I
people ever on the moon? That seems a little high. Let me tell you what this means. This little bar right here means given. Okay, that little bar means given. The probability that I am in Ohio, given that I'm in California.
Excuse me, what?
Zero.
Zero. If I'm in California, the probability of me being in Ohio, given that I'm in California.
Okay, so A is Ohio,
You're
B is
already in
California, right?
California, couldn't you just go to Ohio then?
So the second, I like the language Maddie just used. This right here means I'm already doing this. Okay. What are the chances that this is going to happen? Okay. So if I'm already doing one thing and this will show up in other probabilities where it will make sense. But right now in mutually exclusive, you're either one or the other. You can't be in this and maybe in that.
So A is,
Hold on.
Just for the dice one, if it was an even number, like you suggested, the other two were even numbers, like you suggested, like Dalton suggested, could it work?
Sure. So if we had changed the problem, and I think, let's look at the question C. Okay. So the probability, you roll a standard number cube once. What's the probability you do not roll an even number? Okay. So that's not the question you asked. So what if I had changed E to be this, but you're saying make T to be 3, 4, and 5? Okay. Or for funsies, let's go ahead and make up a new letter. Let's say G, and G is 3, 4, or 5. Okay. So this is so the probability of E and G. I'm sorry?
I was seeing the one with the line. The third one on the.
Like what would be the probability of this E given that T happened? Okay, so he's saying, so this one right here, what is this probability of E given, or E and G? Anyone see it?
I'm writing it down.
It's zero.
No.
Wait, no.
What is it?
Zero. 1 and 3.
4.
No, it's like 1 6.
1 and 6.
1/6.
What?
That's what I was thinking.
Because they have overlap. If G is 3, 4, and 5, and E is 2, 4, and 6, then basically I'm asking what's the probability of 4 happening, which is 1/6. Jonathan, I think, was asking the probability E given that T happened. Okay. Right, we haven't gotten there yet.
Hold on, that would just be 0.
This would be 0. If I tell you that T has happened, it rolled a 3 or a 5. What's the probability that E happened?
0. Because T already happened.
Let me point something out. If I ever ask you, is this mutually exclusive? You have to show me that the ORs do what? Add up. Yes. So, and we'll get to that here in a minute. Okay. You roll a standard cube once. Is that a hand over there?
I was asking about the given. So for given, just to help you like understand, it's saying, so one thing's already happened, what's the probability it's going to happen again?
This is one event. It's key to realize that it's one event.
There's no chance of this happening ever.
It is impossible that I can roll a dice and get a 3 and a 5.
Even if it's like we just explained where it's 2, 4, 6, and 3, 4, 5, would that be?
This is possible.
It's one roll.
This is possible because I can roll once and basically, so if I'm E, if I'm trying to get this and somebody else is G, right? We have some overlap that we both want 4. If you roll a 4, then we're both happy. That is actually not mutual because we have something in common that we want.
Oh, so that would go under, non-mutually exclusive?
Yes.
So why isn't that for the probabilities for non-mutually exclusive, like P, A, B given? And why isn't that written on there for the formulas?
P what?
P, A given B, like why isn't that written on there?
Some of these situations don't make sense to happen,
I thought that,
or they're more advanced than we're going to get.
so that's more advanced than we're gonna get into.
Some of the formulas get really, really advanced. You could take a whole year on probability, and that's when you dive into that. Okay.
Okay.
So our goal is to kind of get familiar with the notation, understand what it's saying, and then be able to do some kind of basic to mid difficulty problems. Okay. So what you roll a standard number dice. What is the probability that you do not roll an even? Okay. So the probability of not even is 3 out of 6. I would accept that answer. I would accept 0.5. I would accept 1/2. Okay, any of those answers are fine.
You would accept 50%.
We usually don't get into percentages. We the more advanced math, we like to just keep it as decimals. Okay, or fractions. All right, so yeah. This isn't super clear to see, but there is a, help me out here by drawing, there's a square right here, and then there's a square right here. And, yeah,
There's just one little square.
well,
You should draw this.
so that you should draw what I just drew. And does it say what colors they are? This one here is green, and this one here is blue.
Oh, it says one's A and one's B.
Oh, okay. Do you want to go with green or blue or A and B? Okay, we're going to go with green and blue. It's been decided. Okay, so first question. Is G and B mutually exclusive?
Yes, at one spot.
Can you do both at the same time?
Yes.
Yes, there is overlap. Can you be in both states at the same time? Yes, if the states are drawn like this. Okay, these are not mutually exclusive. So I'm going to give you the formula. We're going to talk about this in terms of the formula, even though it might be trickier than actually just doing the problem. I bet if I just asked you to do the problem, stop doing that, you could do it, but in terms of the non-mutually exclusive. So non-mutually exclusive is the probability of A plus the probability of B minus the probability of A and B.
There should be 0.
So on the last problem, we didn't need this on there because that equaled what? 0. This time it's not going to be 0. Okay?
Oh.
Oh, wait, so this is a formula?
This is a formula.
Does it have a definition?
Non-mutually exclusive.
So they don't meet, okay.
They do meet.
They do meet.
They do. They have some overlap. Yeah, there's 3 things. Okay. Okay, so non-mutually exclusive. So if we think in terms of this, I'm going to just kind of rewrite that formula here. You don't have to. So it's probably A plus probability B. And I could have used this formula in the last problem because like we just said, that and A and B was 0. Okay. So we have this huge target. How big is the huge target?
20 centimeters.
By 60. So
Yeah.
20 by 60 is how big? How many square feet?
120. What's 100?
1,200 centimeters squared.
Oh.
Okay, that's our target. The rule says you're going to throw a sticky ball. It's going to hit this target. It can not hit this target. Okay, so when you talk about dartboards and probability dartboards, you also have to consider the whole wall, right? Because there are people that throw darts and don't even hit the dartboard, right? I might be one of them. So the probability of let's just go with just G is what?
It's 10 by 10.
10 by 10, which is 100
But then
out of 1,200.
But isn't it something like?
So that's what? 1 over 12.
Isn't it 190 actually for the whole target though? Are we just talking about 1 square? Because if you do 10 times 10 plus 10 times 10 minus 5.
You're getting, no, stop.
Stop.
Yes,
Okay.
just watch. The probability of B is what? The same thing. Do you see how those are exactly the same?
Yeah.
Okay. Are you writing this down?
I'm kind of staring blankly at the screen.
Okay. The probability of hitting A, oh, I used B. Oh, yeah, we did B. So the probability of hitting the green and the blue
Is 1/24.
25 out of 1,200.
What? Oh.
That's the overlap. Where on mutually exclusive, that would have been 0
Why?
because they would not have touched. Remember our Venn diagram? Okay. So what is 25 divided by 1,200?
148.
Is that right? Wow. You did that in your head?
What did they say it was? 148.
That's good.
Let's hold on for it.
It's 148. So let's talk about this formula. The chances of hitting the target, according to this problem, and I don't care where you hit it. So the probability of hitting G or B equals 1/12 plus 1/12 minus what? 148. And we're strictly just looking at the formula and going with it.
Why minus 1? Oh, no.
748.
And it equals 7/48. So if we had done this problem without this formula, okay, we would have started, and I'm just going to rewrite it here. What's the probability of hitting G? 1/12, or let's call it right. How much space does G take up? 100. And how much space does B take up? But you can't say 200 because why?
Because they overlap.
So we would say 200, but what would we do with that overlap?
Minus 20.
We would subtract 25 out of 1,200.
Oh my gosh, that was so much confusing.
It is a lot more complicated. So that's what, but the formula is still doing the same thing. We're adding this, and then we're subtracting the overlap. So let me tell you this. If this is on the test, and don't worry about any of this stuff, just answer how you know how to answer it. But the reason why we have to show this, all this notation, is there'll be questions on the test that look like this. That'll say probability of G is this, probability of B is this, probability of B, G and B is this, and they'll ask you to find what this is.
Oh, that's the puzzle one.
Okay? So it's all about the notation, yes.
It says what's the probability of hitting inside one or both, so the middle doesn't matter.
One or both. So they're saying
One, so either G
Yeah, you
Or
can
B.
hit either
Or
one
in the
or
middle,
both.
so it's 175 over 1.
Because the center's been counted twice. If I did 100 and 100, it's counted twice. That's where this formula comes from. It's saying this plus this, but if they overlap, you got to subtract their overlap. That's why mutually exclusive, this part right here is 0. There's no overlap. You're either there or there.
I'm still not understanding how you got 112 plus 112 minus 48 equals 48.
So the probability of G was the area of G divided by the area of the whole thing. Got that? And then B was the same. And then the probability of hitting G and B is this little square right here, which is 5 by 5, 25 out of the whole thing. And then the formula just tells us this plus this minus that. Did that help?
Now I understand. You have to convert it into 48. Yeah, 448.
Yeah, Ben pulled this out of his brain, which is impressive to me. But.
He uses phone. I'm just kidding.
Don't tear him down. Let him be. Let him be smart. Okay. Independent. So independent means what? 2 events. Okay. So let's go ahead and define independent real quick. Okay. So it's key to understand this, and I'll give you this little notation right there. That's supposed to be like a U. I'm sorry this got cut off. Independent. 2 or more events that, anyone know?
That happened at the same time.
Not necessarily have to happen at the same time, but
That happened.
That occur within the same story that kind of
Okay.
the outcome.
but what makes an event independent compared to another?
That it has no effect on the other one.
Okay, that has no effect. Is it A or E?
A.
Effect, it's E.
There's effects and defects.
2 or more events that has no effect or effect or affect, whatever, on each other. Okay? Can anyone give me an example?
I have a bit comparing oranges to apples.
Not close enough,
Okay.
or not independent enough for me.
I am in Ohio and my cousin.
Okay.
No.
Well, let's look at some problems. I think you'll be able to see whether it's an independent or not, but I ask you to prove it. Okay. I'm going to give you. Yes.
Oh, I was just going to tell you on
Okay. So a jar contains 12 green marbles and 8 violet. Okay. A marble is chosen at random from the jar and replaced. Another marble is chosen at random from the jar. Does the color of the first marble affect the possible outcome of the second marble?
Yes, it does, because if you replace the one from the first, well, it could or it couldn't. It just depends on what you replace it with. But if you, like, say you replace it with the same color, then it wouldn't. But if you change the color, then it's gonna mess up the ratio.
Okay, so they're pulling out a purple one, for example. They're taking that one they took out and putting it right back in. They're not like eating it or whatever. Okay, so if I take something out and I go, oh, I'm on the purple team, I throw it back in there and I shake it up and then ask you, it's still the same odds. Okay, so this one is independent. Now, it doesn't say, tell me whether it's independent or not. It says prove it. So I'm going to give you the formula for independent.
Because you take it out. If I put all of our names in a jar and then I pulled your name out and then I stuck it back in, that doesn't change the odds of someone pulling
Say
your
again?
name.
Why does it use that phrase in place? Why doesn't it say take it out and put it back in it?
In probability,
It says replace, which means
Right.
Or to place back
Yeah.
in.
When did that ever meant that?
Well, you're redoing a
This is like my little brother who likes to be in the family.
Which means to put you back in.
His
Yeah.
little brother is not him.
So it does. So to replace means to put back in the exact same thing in probability. And I see your argument. To not replace means to just completely take it out. Okay. So in probability, if they say and replaces it, if I take out a deck of cards, you pull out the card and I replace it, it means to place it back in. I agree that the language should be places it back in or returns it. Okay. But replace is a common term in probability. So when you ask questions in probability, people might go, oh, is it replaced or not replaced? That's the language that they use, as odd as it is. So the probability of A and B is the probability of A times the probability of B. So if I ever ask you to test something, test to see if something's independent, then you have to find the probability of A, find the probability of B, multiply them, and show that it's the same as this. If it's not, then it's not independent. Same with anything on this sheet. If I say prove that it's mutually exclusive, then you can go to here and you can show me that these two things add up to that. These are all tests for things. Okay? Yes.
Can you do an example with mutually exclusive?
Yes, we will get there.
Okay.
Okay? I'm just kind of foreshadowing. So to prove that this is independent, I got to do the first thing. So I'm going to go ahead and call it the probability of A is the first thing I'm going to do. Okay? Now, if I pull out let's just go ahead and pick one. Pick green or violet.
Violet.
Okay, so probability of violet, okay, for the first one, so V sub 1 is what?
Like 8 out of 12.
8 out of
No, and 20.
20. And we won't even simplify for the sake of time. Okay? I put it back in, and then I say the probability of V the second time is what?
8/20.
8/20.
Would that be
The
same?
probability of doing V and V2 should be the same as multiplying those. Okay?
So if you do 8/20 times 8/20,
Yep.
be 64 400. 4,000.
64,400.
I would simplify this to 4/10 and it would make it a lot easier.
Okay.
Or you do 7. That's it.
Yeah.
7.
So, I'm confusing myself, sorry.
I confuse myself all the time. I confuse more people.
So because these end up giving you this, then it's got to be independent. So we know that this is what happens when you do V1 and V2. Okay? So the second one, it's not replaced. Is it independent or and this is one thing that's really weird is we don't use dependent. We use not independent.
So it's not.
So this one's not independent because probability of V1 is going to be 8 out of 20, but the probability of V2 is going to be what? 7 out of 19.
Well,
And if I multiply those, it's not going to equal that.
okay.
Okay? So this is not independent.
That makes sense. That's what the-
Which part?
Every part.
Oh. Mark, you have to open up your brain.
Open your mind.
If I'm able to understand, you definitely.
Okay, so we got to kind of fly through this here. Alex cannot decide what to wear today. She chooses at random, so you obviously can't see the colors, so I wrote them on there. What's the probability of rain today? The probability of it's going to rain today is 40% or 2/5. What's the probability of that Alex chooses yellow and it does not rain? So you can do and, not, are.
So it's 60% and 50%.
So you first have to ask yourself, are they independent?
Yes.
Yes. The color of your shirt doesn't matter whether it's going to rain or not. Okay. So if it's not independent, we can think of this formula. It says take both events individually and multiply them together. The probability of picking yellow is what? 2 out of 4.
What? There's.
And the probability that it's not going to rain is
60%.
3/5.
Rachel.
So the probability this is going to happen is 6 out of 20 or 3 out of 10.
Which is 30%.
Okay. Get percentage. I don't want percentages.
Why not?
I either want fractions or decimals. Okay. What is the probability that Alex chooses yellow shirt and it does not rain? Or the probability that Alex chooses a yellow shirt and does not rain?
We take the 0.3 and then add it to the new scenario.
Or Alex chooses a green shirt and it does rain.
They're completely unrelated.
So there we go. So we just had two situations where we're going to throw the or in there. Okay. Is it mutually exclusive?
One of them is, one of them
Yes.
isn't.
Can it rain and not rain?
No.
No.
Can you wear green and not green?
Depends.
So it's mutually exclusive. Okay.
Yeah.
So we're going to figure out, so it's the probability of this first event and the probability of the second event and any overlap if there is any. So we'll talk about that in a second. So the formula is the probability of the first plus the probability of the second minus any of the overlap. And for time, I'm just going to write and, blank, blank, and. Okay? So if there's overlap. So let's just talk about the probability of this first thing was 3 out of 10, right? Probability of green is 1/4. And probability of rain was 2/5. So together their probability was 2/20 or 1/10. Is there overlap?
No.
There's no overlap. That means this right here equals what? 0. So it's this plus this minus 0. So that equals, I like 2/5 or I like 0.4, huh? Yeah, I'm sorry. This is 1/10. I simplified it. This is redundancy of what we've already talked about. If we had more time, we would just say it again. Mutual exclusive, probably this and that. It's just that formula sheet. Okay. So down here, determine if A and B are mutually exclusive. So what does that mean to be mutually exclusive? That means that the probability of the ors have to add up. So anytime they ever ask to test to see if something happens, basically we look at our formulas. Determine if it's mutually exclusive. Mutually exclusive means that the probability of A plus the probability of B equals the probability of A or B. And I'm writing gigantic for how much space I have. So if I go off here and give myself some space, then that means probability of A, which is 2/3. Yep.
Like 2/3. plus 1/5, does it equal 13?
Yes.
I don't know if it does. 13, 1/5.
Okay. So it does 2/3. So if we plug in a number plus 1/5, does it equal question mark 13/15? If it does equal, which I'm being told it is, then the answer is, if it checks, then yes. Mutually exclusive. So the next one, same exact formula. Okay. Does 3/5 plus 2/7, does that equal 28/35? That's no, does not equal. Then we say not mutually exclusive. Okay, because there's some overlap that's going to be subtracted out. You could almost ask the question, what is their overlap? And we should be able to find it because there's a third thing that's getting subtracted that's messing this up.
Oh.
Right? So we could jump to this formula and say, well, then figure this out because that's the only thing that's missing. This symbol right here, anyone know what that is?
It's something that was on my Reddit.
It's a union. Okay? Union is another word for or. Okay? So, and this one here, anyone want to guess what this is? This is called intersection, but it also means and.
One's up, one's down.
I think of or as being easygoing. Okay? You can throw anything you want in there. You're welcome. Group quiz is that sheet, the second sheet you got. So make sure you have that.
Okay, so couple of things that what was that called again?
And.
And? But no,
And.
like what's the
A
name
and
of
B.
it?
Intersect.
Intersect.
Yes, I would love.